Here we are in section 3-1, exercises 9 through 17 with the solutions. First of all, we're going to review some division. 6 into 734, 6 goes into 7 one time. 1 times 6 is 6. Subtract and we get 1, drop down the 3. 6 goes into 13 twice. 2 times 6 is 12. Subtract and we get 1. Drop down the 4. 6 goes into 14 twice. 2 times 6 is 12. Subtract and we get a 2. So we could write the answer as 122 and 2/6. Oh, that simplifies. Divide by 2, and that is really 1/3. Or we could keep going and do some decimals here. 6 goes into, let's put the decimal right up there, 6 goes into 20, and we get a 3. 3 times 6 is 18. Subtract and we get a 2. Drop it down, we get a 0, and we're now going to repeat the pattern. So that's 122. Oh, we knew that. 0.3 repeater is the same as 1/3. Good. Number 10. 11 goes into 393. So 11 goes into 3. Nope. 11 goes into 39. Yes, indeed it does. 3 times. 3 times 11 is 33. Subtract and we get a 6. Drop down the 3, 63. 11 goes into 63 5 times. 5 times 11 is 55. Subtract and we get an 8. So we could leave it as 35 and 8 is the remainder, 11ths. Or we could keep going and do a couple of decimal places. Let's see what happens there. 8, 0, 11 goes into 80 7 times. Let's put that right there. 7 times 11 is 77. Subtract and we get 3. Drop down the 0. 11 goes into 30 2 times. 2 times 11 is 22. Subtract and we get 8. Drop down a 0. And we're going to repeat the 7272 forever. So 35.727272. All right, number 11. We're going to move the decimal twice. So we get 7 goes into 5198. So 7 goes into 5. No, 7 goes into 51. Yes, it goes 7 times. That's 49. Subtract and we get 2. Drop down the 9. 7 goes into 29 4 times. 4 times 7 is 28. Subtract 9 minus 8 is 1. Drop down the 8. 7 goes into 18 twice. 2 times 7 is 14. Subtract and we get a 4. So that would be 742 and 2/7. If we kept going with a decimal, I remember 7ths are not, it takes like 6 to repeat, but let's see what we get here. So point. Okay, so 7 goes into 40 5 times, which is 35. Subtract and we get a 5. So let's start up here. Drop down a 0. 7 goes into 50 7 times. That's a 49. Subtract and we get 1, 0. 7 goes into 10 once. 1 times 7 is, let's put this line here. 1 times 7 is 7. Subtract and we get 3. Drop down a 0. That's 30. 7 goes into 30 4 times. 4 times 7 is 28. Subtract and we get a 2. Drop down a 0. 7 goes into 20 twice. 2 times 7 is 14. Subtract that and we get a 6. We're going to start up higher again. Drop down a 0. 7 goes into 60 8 times. 8 times 7 is 56. Subtract and we get a 4. Drop that down and we get a 0. And you'll notice we're going to start the whole pattern over again. So 571428. 571428, and that whole pattern repeats. Whew, that was a long one. Long division is pretty tough there. We're going to multiply fractions here now from 12 to 17. So number 12, and we're going to practice what we just learned, that you can simplify ahead of time. So in slow motion, you could take 2 times 3 is 6. 3 times 7 is 21, and then divide by 3 and divide by 3 to simplify. Or you can divide by 3 and divide by 3, and you get 2 times 1 is 2, over 1 times 7 is 7. Yeah, this canceling is amazing. Okay, and notice you'll get the same thing either way, but 2/7. So we're not going to do the long way. We're going to pre-simplify in practicing for the unit conversions. Okay, number 13. We have 2/7 times 3/11 times 7/3. Is there anything on the top, anything on the bottom that can cancel? Notice this 7 can cancel with that 7. They both leave it just a 1. And that 3 can cancel with that 3. So yeah, we get 2 on the top and 11 on the bottom. Look how nice and slick that is. If you did it the big way, 2 times 3 is 6 times 7 is 42, and 7 times 11 is 77, times 3 is 237, something like that. 230, yeah. Anyway, 231. Anyway, you times that up, and then you could reduce by a 7 and a 3 in top and bottom, and then you get 2/11. But yeah, this canceling ahead is nice. All right, number 14. Ooh, see what we can cancel there. It looks like there's a 3 and a 5 and a 2. So that gives us 7/11. Oh, I like it. I like it. Okay, next one. Ooh, 10 times 21, 60. They don't cancel exactly, but if you remember, this is really a 2 times a 5, and this is really a 3 times a 7. And this is a 9 times a 7, which is 3 times 3 times 7. And this is 5 times 11. So let's see what can cancel. A 5 and a 5 and a 3 and a 3 and a 7 and a 7. We get left with 2 over 3 times 11, 30/3. There we go. And you could have done it just a little bit differently if you would like to. Let me see, 63 and 55. You can see a 5 here and a 5 here, so you can cancel it to a 2 and an 11. And if you can see that you have a 7 in both of them, 9, 3, and then take the 3 out, and you're left with 2 on top and 3 times 11. So that may work just as well as writing out the prime factorization. Okay, so next one, number 16. So let's try that here. We can see that 10 and 55, they both have a 5 in them. So this is going to be a 2 and an 11. Good. Can you see that 33 and 11 both have an 11 in them? So that'll be completely gone. 42. That one I don't know as well. This is 6 times 7, so it's 2 times 3. Oh, times 7. So you can see the 3's will cancel, and the 2's will cancel. So on the top, we're left it all divided out to 1. It's not a 0. They canceled to 1, and then a 7. 1/7. Good. And the last one, number 17. Let me see. 22 and 33. So 22 and 33, they both have an 11 in them. That was kind of nice. Let me see. 55 and 20 both have a 5 in them. So we divide out the 5. You see 2 and 42, you can divide 42 by 2, and that's 1 over 21. 9 and 3 have a they both have a 3 in them. Divide it out, and you get a 3 on the top. So you get and a 3 and a 21. 7. So you get 4 over 77. Let's do that with prime factorization just so we can see it. So 22 is 2 times 11. 42 is 6 times 7. And then we times 9. That was 3 times 3. 55 was 5 times 11. Yeah, you break it up, you can see what's really in there. And then on the 20, we had that's 4 times 5. So that's 2 times 2 times 5 over 33, which is 3 times 11. Yeah, now once you break it down to that prime factorization, you can see that the 3 cancels, the 3 cancels, the 2 cancels, an 11 cancels, a 5 cancels, and then we look at what we have. We have on the top a 2 times a 2, and on the bottom a 7 times an 11. So that actually was pretty slick. That prime factorization really helped out there. Great.